Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on loss of energy due to sudden contraction. In our previous video lecture, already we've discussed the theory part and the derivation of sudden contraction. And this sudden contraction is coming under the minor losses. So let's solve this problem. A horizontal pipe of diameter 500 mm is suddenly contracted to a diameter of 250 mm. The pressure intensities in the large and smaller pipe is given 13.734 Newton per centimeter square and 11.772 Newton per centimeter square. Find the loss of head due to sudden contraction and the rate of flow. Consider Cc equal to 0.62. So we need to find out two things. One is the loss of head due to contraction and the rate of flow. So these are the data given in this question. So first let's write down the data given for this question. So the data given in this question is, let's consider first one, diameter of the pipe is suddenly contracted. That means D1 here given. Let's consider this is D1, the larger pipe diameter, that is 500 millimeter. So this 500 millimeter we can write into meter also. So this is 0.5 meter. And this one also immediately we can convert into area because area is required everywhere. So we can calculate the area of this pipe, that is pi by 4 d square. So 0.5 square we can write. And after getting solving this one, we can get the answer. Similarly, this pipe is suddenly contracted and it is compressed, we can say, to a diameter of 250 millimeter. So in that condition, the diameter D2 is given 250 millimeter. So this one also we can write in terms of meter. So this is 0.25 meter. And again here also we can write the same thing. Area of that smaller pipe, this is A2. Similar formula we can apply. This is 5 by 4 D2 square. That means 0.25 square equal to, we can write it here. Now the next value is given, the pressure intensity is at the larger pipe. So pressure intensity at the larger pipe, so you can write P1. This is given 13.734 and this is Newton per centimeter square. Similarly, the pressure intensity in the smaller pipe, so that is P2 we can write 11.772 and Newton per centimeter square. As we are converting all these units into meter square, so this one also we can write in terms of meter. So that is nothing but 13.734 into 10 to the power 4 Newton per meter square we can write. Yeah. Similarly, here also you can write 11.772 into 10 to the power 4 Newton per meter square. Okay. Yeah. Cc also given here. So let's write the coefficient of contraction is Cc. So this one also 0.62. So these are the data are given in this question. Okay. Now for this concept, let's draw the diagram one. So suppose this is the pipe is there with a diameter of 500 millimeter and suddenly it is compressed or contracted to 250 millimeter and the liquid is flowing through this. So now we can write this. So this is the direction of flow. Okay. And this is the larger diameter. We can mark it here and this is the smaller diameter. This is D1 and this is D2. Now here what you need to calculate actually, we need to calculate the loss of head due to contraction. We need to find out two things. One is loss of head due to contraction. This is HC and the rate of flow is nothing but Q. These two things we need to calculate. So HC equal to, we have seen that formula yeah, SC, we know that formula. Let write here. Let's change this one. So HC equal to, we know that we have seen in the previous lecture, the formula we got here. This is V2 square by 2G, and bracket start 1 by Cc minus 1 whole bracket square. Okay, so this is the value of VC, sorry, HC. So now we can just simplify this and we can get it like V2 square and divided by 2G, and here bracket start 1 by Cc value is 0.62, and this is minus 1 whole square. So this one also you can calculate it here with the help of this calculator. Let's solve it. So this is nothing but 1 divided by 0.62, yeah, minus of 1 and square of this. So this is again square of this, yeah, 0.389. Let's do it again. 1 by, yeah, 62 is there, correct. So 1 divided by 0.62, yeah, okay, we got this, minus 1, this one, okay. Now we got this, again minus 1 came. Okay, again it was subtracted, not that much. So what we'll do, 1 divided by 0.62 minus 1 as square of this. So this is nothing but 0.375. Yeah, now you can write 0.375 into V2 square by 2G. So this is the value of HC, that means the head of contraction, or that is the loss of head due to contraction. This is the equation, but we need to calculate the value HC, how much. So here we can see the V2 is unknown here, so V2 is not given in the question, so we need to calculate this V2 value. So we know that one more thing we can write as per the continuity equation. We can write as per the continuity equation, we can write A1 V1 equal to A2 V2. Now here it is difficult to calculate the V1 and V2, though A1 A2 given, but V1 V2 need to be calculated if it is difficult here, because Q value also not given and Q also we need to calculate, correct. So what we will do here, so let's write this equation in terms of one single value, like V1 equal to, you can write A2 V2 by A2 V2 by A1. Okay, now here what I'll do, I'll just put this value of pi by 4 d2 square, again denominator pi by 4 d1 square into V2. So pi by 4 will be cancelled. So here we can write this is d2 by d1 whole bracket square into V2. Okay, now d2 is how much? d2 is 0.25. So again we can write this is 0.25 divided by 0.5 bracket square and V2. So 0.25 by 0.5, that is nothing but 1 by 2. So we can get a square of this, that means 1 by 4. So here we can write this is V2 by 4. So V1 equal to V2 by 4 we can write. Okay, now here again one more value is there, A1 A2. Let's find out this, that is pi into 0.5 into 0.5 divided by 4, so 0.196. so this one we can write 0.196 meter square. Similarly again this is pi value, pi into 0.25 into 0.25, again 0.25, this divided by 4. 0.0490. So here we can write 0.0490 meters square. So two things we have calculated. Now, after applying this continuity equation in this, we got this value. So now we'll go for the, because see, here neither the q value given, neither v1 given, v2 given. So difficult to calculate the velocity v2. We require this v2 value. So what we'll do, we'll go for the Bernoulli's equation. So we know that, so Bernoulli's equation, let's write here, P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 and plus the loss of head due to contraction. Now here actually this is section 1 and this is section 2. Okay, so where the section 1 and section 2, now before contraction we need to consider section 1 and after contraction we need to consider section 2. So these things need to be, this is 1 actually, yeah, section 1, this is section 2. Now, so after applying this Bernoulli's equation, just put all these values of P1 and V1 values, V1 not given. Anyway, so now we can see this Z1 value and this Z2 value both will be similar because this pipe is horizontal pipe. So we can write Z1 equal to Z2. Now, V1 place we can put V2 by 4 and HC value is nothing but what we got there, 0.375 V2 square by 2g. So that we can put value here. So after putting all this value, what I can write, P1 value actually how much is there, 13.73. So let's write 13.73 into 10 to the power 4 and divided by P1 by rho g, rho equal to here, so 1000 into 9.81. So we can write 9810 plus V1 square. So V1 place we can put the value of V2 by 4 whole square and divided by 2g. So 2 into 9.81 plus Z1 is not there, so Z1 leave it, equal to what we can write. What is the P2 value? P2 value is 11.77 into 10 to the power 4. So let's write down 11.74 into 10 to the power 4 and divided by rho g, again 9810 plus V2 square. So the value of V2 square will keep it as usual, same V2 square by 2g. And Z2, Z1 already cancelled here, so no need to write. HC value we can put it here like 0.375 V square by 2g. Okay, so this is the equation. Now let's solve it one by one. So 13.73, so 00 and divided by 9810, so 13.99, that is nothing but 14. So 14 plus we can write this is V2 square divided by this 4 square 16 into 2g. So 16 into 2 into g, 9.81, 313.9. So you can write 314 equal to, again just multiply the value, 11.74, sorry, vice point will give, directly write 77400 divided by 9810, 11.96, so you can write 12, and this is V2 square by 2 into g, so 2 into 9.81, So we can write 2 into 9.81, 19.62, 19.62 plus V2 square by 2G into 0.375. Okay, so this is the equation now. Now we need to solve this equation. Let keep all this value numerical one side and V2 square one side key value. So 14 minus 12 equal to, here we can write V2 square by 19.62 minus plus 0.375 V2 square by 2G. So 2G here also we can write the value 19.62 and minus this one, will get this value V2 square by 314, or that is nothing but also is just previously what we got, same thing we can write. This is 2G. Okay, this is 16 into 2G, initially it was there, now this is also 2G and this is also 2G. Okay, here already I have written the 19.62 value anyway, this one. So now if you subtract this value, we'll get what we can get here 2, and here how much value we'll get here. Now if you take common of this V2 square by 2G, okay, let's do one thing, V2 square by 2G, take common here, and so what will get this one, 1 plus V square by 2G gone, 1 plus this is there, yeah, 0.375, and here minus 1 by 16. So let's do one thing, 1 divided by 16, 0.0625. So this minus 0.375 minus 1.312. So this is not minus, I have done reverse, so we'll get 1.312. So this is nothing but we can write, so V square equal to, we can write 2 into 2G, and this is here we got how much, 1.312. So 1.312. So let's write one more step here. This is V2 square by 2G into 1.312. Okay, so now these things we can take it to this side so that it will be divided here. So same thing we can get it here, like V2 value we supposed to calculate. So now, yeah, we will divide it here, 1.312. Let's see how much is coming. 2 into 9.81, yeah, divided by 1.312, 29.9. So 29.9 root over of this 5.46. So now this one, let V2 equal to, directly right here, 5.46 meter per second. So this is the velocity. Now once we got the velocity, immediately we can able to calculate the value of, you see here, what is the value required? HC, the head loss due to contraction, and the rate of flow. So these things we can easily calculate by implementing the value. So first one is HC equal to, we know the value, 0.375 into V2 square. V2 square is nothing but 5.46 square and divided by divided by 2G. 2 into 9.81. So let's calculate this, how much we'll get. 5.46 square 5.46 square into 0.375 and divided by 19.62, 0.569. So this is HC. SC equal to 0.569 meter. The same I got 569. Anyway, so this is the loss of head or loss of energy due to sudden contraction. Okay. Now second is Q, the rate of flow. The rate of flow is nothing but A2, V2 we can write. So here A2 value we got here already, 0.0490. So 0.0490 into this 5.96. So this again we can multiply. Yeah, 5.96 into 0.292. So this is 0.292, this much meter cube per second. If you want to convert into 0.29204, if you want to convert this into liter per second, also you can write 292.04 liter per second. So this is the answer of rate of flow. So I hope you understand what we have done here. Let me tell you briefly. So here the question is given for a sudden contraction. That means a pipe flow is there whose diameter was 500 millimeter, and suddenly it was contracted to a diameter of 250 millimeter, and the pressure intensity at the larger pipe, for this larger pipe, the P1 is given 13.734 Newton per centimeter square, and this for small pipe, the P2 pressure intensity 2 for this is given 11.772 Newton per centimeter square. For this question, we need to find out the loss of head due to contraction, that is HC, and we need to also calculate the rate of flow, that is Q. So HC equal to, we know that formula, this formula, HC formula is this one, and Q equal to, we know that A1 V1 equal to A2 V2 we can write. Okay. For to calculate the Q, the rate of flow, we must require the velocity, because diameters are given. So from that we can calculate the area calculated, and pressure value given. Now this is the value of HC, the loss of head due to sudden contraction. So here this value we need to find out, V2 square we need to find out, so that we can calculate the Q as well as we can calculate the loss of head. So for that we require the Bernoulli's equation. So Bernoulli's equation is this. This is the Bernoulli's equation. From this we can find out the value V2, because we have already converted the V1 in terms of V2. So only one unknown will be there here. That is here also we can write this is Z1 equal to Z2, so that we can write this equation. Okay, it is a horizontal pipe, we can write it. So from this equation we can find out the value of V2. Once you find out the value of V2, then we can go for the HC and we can calculate the Q value. This is the answer. So I hope you understand this problem. If you are having still any doubt regarding this, you can give a comment in the comment box. Thank you all.